Welcome to the Ivy Curve module. We said something about the Ivy Curve before now. So we are going to dissect the Ivy Curve of a solar panel so that when you look at the solar nameplates, you can understand what happened before those parameters are recorded. If you are talking about any solar panel and you don't understand the IV curve, I believe there is problem somewhere, or you don't understand the solar nameplates. There is always a problem somewhere. The IV curve is plotted in the laboratory under certain condition. The parameters on the nameplates are not recorded in an open field. Those parameters are conducted in the laboratory when the solar panel is subjected to some constants, and the values gotten when you subject the solar panels into those conditions are recorded. We heard about Boyle's law and Child's law. When those experiments are carried out, or when those experiments were carried out, they were carried out in the laboratory under standard conditions. So when you look at the nameplates of any solar panel, those readings that you are seeing are gotten under a controlled environment. It's not conducted in an open field. So it's not possible to have those conditions in an open field. So here is your IV curve. This is an IV curve of a 12-volt solar panel, and you know that the IV curve is always plotted, the voltage is always plotted along the horizontal plane, whereas that is the horizontal axis, whereas the current is plotted along the vertical axis. If you are talking about any solar panel, the solar panel IV curve characteristics will always show the current voltage characteristics of the photovoltaic solar panel. The IV curve, I have already said that the IV curve will always give you an in-depth knowledge of a solar panel's conversion ability and efficiency. That is, a proper understanding of the IV curve of a solar panel is critical when determining the panel outputs and efficiency. When you are talking about the IV curve, it is what normally gives us an impression as to the output of this solar panel. We are going to delve into maximum power points of a solar panel, the voltage at maximum power point, the current at maximum power point. This is the point A, and we are going to talk about the short circuit voltage of a solar panel. and we are going to talk about the voltage, open circuit voltage of a solar panel. The IV curve is conducted in the laboratory at standard test condition. What do I mean by standard test condition? That means there are some uh, parameters that are kept constant before the nameplates. The parameters on the nameplate are recorded. That means the solar panel was conducted under the parameters on the solar panel was conducted under a standard test condition. So when we are talking about standard test condition, the solar panel will be subjected to a 1000 watts per square meter irradiance or illumination. What do we mean by that? That means the amount of solar energy per unit area arriving on a surface of a particular solar panel at a particular angle. Then there is always a cell temperature that the solar panel will be subjected to. The solar panel cannot be, we already know that the cell temperature of a solar panel greatly affects its performance. When the illumination is small, the solar panel might tend to produce a lower power as against when the cell temperature is a bit higher. And when you subject your solar panel to a very high temperature, it might tend to affect the efficiency of the solar panel. We will still get to understand this. And a 1.5 spectral condition. When we are talking about spectral condition, we are talking about atmospheric temperature or pressure of the atmospheric condition that the solar panel is subjected to. So these are some of the standard test conditions that any solar panel that the manufacturers produces. Depending on the company, these are the conditions that the solar panel will be subjected to before when a particular result is gotten. Those results will be put on the nameplate to tell you that if you are able to subject that particular solar panel to such a condition or conditions, the rating of that solar panel is exactly what you have. So in essence, there is always a variation in what you have if you test those parameters in an open field. If you test those parameters in an open field, you are not certainly not going to have exact figures on the nameplate. So because you have not been able to subject the solar panel to the standard test condition that it was subjected to during production. So that is what Ivy curve is all about, and that is how the parameters on the nameplates came about. Welcome.